Our last sponsor session today comes from Huawei, Dr. Ning Wu and Dachuan Huang.
Okay, thank you. I'm very honored to be here, and this presentation will be presented by me and my colleague together. So our topic is about our innovation about the whole stack for artificial intelligence, including the computing, software, and also storage. So when we talk about the artificial intelligence, scaling law is the one which can push the ICT industry, especially for the computing, going forward. So not only for the pre-training area, but also for post-training, supervised fine-tuning, and even now for the multi-agent environment. The one direction is for sure to add the parameter. For example, from the multiple billion to even the trillion, more than 10 trillion parameter. That is a definite direction, and all based on that to add the computing power to support this. That gives us a clear direction for us to go. So when we consider about the computing power, there are several things we need to consider. The first one is about the infrastructure which can provide more computing power. For example, the couple system, scale-up system, to more computing power and more memory access, including the high bandwidth memory, and to break the memory wall. That's the first one. The second part is about the communication. Yes, when we try to build a large-scale cluster, to today, I know that the biggest cluster of single cluster is around 500,000 physical nodes in one cluster. That means the networking is another thing we need to consider, to not only for the bandwidth, but also for the scalability and latency or such things. The third one is power consumption. So, but today we will focus on the major two parts: the computing, networking, and the third one is about the storage. So for Huawei, this year, our strategy is very clear. It's all intelligence. So based on this strategy, there are several things we will focus. The first one is about the ICT infrastructure to support the AI. For example, we design our own chipsets and produce our own chipsets. That is the first one. And we also develop the new technology to support both the scale up, scale out, and even scale across networking to support a much high scalability of the networking. And the third part is storage. For the warm storage and also for the hot storage, we all support various kind of storage. That's for the ICT infrastructure level. And above that, actually, for Huawei, we will also invest a lot on the fundamental training to train our model, and also help our customer to train their model, their industry model, to accelerate the application of the AI in their environment. So for software, we develop the whole portfolio of the software and also when you do the training, we can help you to use our training framework. We call it MindSpore and also MindIE, which can help you to build the inference environment, inference framework. Here I want to talk about our MPU. We call it MPU. MPU actually is the core to process the AI. So in the ICT industry, there are several different kind of direction of the MPU. For example, some of the vendors provide the ASIC-based, right? ASIC-based normally used a lot by the OTT, and some provide the GPU-based. And for Huawei, we provide our MPU. The direction of the MPU and also from others, the GPU, the direction is the same to improve the computing power of the cube computing power and also the vector computing power. For example, if you train the transformer model, there are several phases. For example, for the FFN, and also when you do the calculation of the QKV matrix, you will use a lot of the cube computing power. But you still need to use the vector. For example, when you try to do the residue connection, and also to use the activation like the glue, ReLU, such function, you will use a lot of the vector. So for the first generation, nowadays Huawei have already released the fourth generation of our product. We call it the 950. But before that, when we released our first generation, we focus on the cube calculation. So today we know that we need to balance that. So we provide the double of the computing power, or the vector computing power, that give us more computing efficiency, especially for the glue, ReLU, and also softmax or such things calculation. And this year, we have already released one chipset of our fourth generation chipset. We name it as the Ascend 950 PR. PR means prefill. That is, we know that for prefill, one requirement for prefill is the computing power, not on the memory. So the second phase, in the second half of this year, we also will release another model. We call it the Ascend 950 DT. That means decoding. This chipset will give you much more high bandwidth memory for you to help you to do the long context inference and training. So that's our plan for this year. And next year, we also will release Ascend 960, and also in 2028, our plan is a 970. So, sorry. Here are several strengths I want to emphasize here is, for the fourth generation, our innovation, there are several ones. The first one, we support FP4. That means that will save you a lot of high bandwidth memory. So FP4, we are the first vendor to support FP4 to do the inference. That's the first one. And also we support the SIMT, that is single instruction, multiple thread. So if you use a PyTorch to do the programming, it will very easy for you to use this one. Very similar way. So that's the set. And the third of our innovation, we introduce a unit, we call it the collective communication unit, that will deal with collective communication, like the or reduce, or gather, or such things, individually, separately. So this will highly improve the communication between the GPU, between the MPU. The next one I want to talk about our SuperPOD. So based on the chipset, we can build a highly scalable SuperPOD. So for the MPU side, which can scale even to 8,192 MPU card in one SuperPOD, then this technology was feasible because we introduced one of the innovative networking technology. We call it the unified bus. By the unified bus, several key features. The first one is a congestion control, very smart congestion control. Then adaptive routing to help you to build a scalable, even based on equal cost multipath. The third one is about the native memory semantic. That means which can support load and store natively. You don't need to translate. You don't need to the copy of the data. So this highly improve the whole efficiency of the SuperPOD, which can make the SuperPOD as a pooling computing, pooling memory, pooling storage. Okay? Here is the use case. Focus on several kind of use case. The first one is internet recommendation and industry intelligence. We can use the air cooling model to do that. And even for the National Intelligence Computing Center, we can use the liquid cooling of the superpod. So that's all for my part. Next, more attractive is about storage. I will transfer to my colleague. Thank you.
Thank you. Good afternoon. So my colleague just talked about computation and models. Let's not forget the third pillar of AI, which is data. So next, I'm going to introduce Huawei's AI data platform. First, I would like to say that right now we're in a quite interesting stage of AI journey. A lot of people said we're at the doorstep of AGI. I won't challenge that statement, but as we know that things are changing rapidly, particularly in the domain of applications and also agents. So how many of you tried OpenClaw? Okay. So OpenClaw is something quite popular this year. That is a general task agent that can interface with your selection of models and memory. So what's interesting is right now we're not only testing models in labs, we're trying to put agents into production. So that brings a lot of challenges. Number one is the cost. If you use the OpenClaw, you know that agents will send lots of tokens. And also, right now, the existing infrastructure is not built to scale AI to production scale. And if you're an enterprise that is already using hybrid cloud, multi-cloud, you'll find the data might be distributed into different places. And therefore, you need to have access to all those data. And one agent won't be enough. So you're going to have a multi-agent environment, which will give you a composable problem, which is how to put all these agents together. And data is also in explosion. It's not only the data that we can see, it's also generated by agents. So if I'm using medical as an example, old days we use traditional images, which is not quite big. But while the technology advances, we're having digital pathology, and later on, when the bioscience is improving, we might have personal treatment, intelligent pathology. So all these are generating tons of data. And agents also generate different types of data as well. For example, for different domains, people might train domain-specific models. And we also like to record the decision-making of agents, collect the trajectories, and not to mention the vector knowledge base and the RAG. And all these will not only ingest different kinds of data, but also generate different kinds of data. So that makes a change to the traditional role of storage. In the old days, when we look at storage, we look at capacity, IOPS, and reliability. But now, the goal is try to feed GPUs with relevant data as fast as possible and as accurate as possible. So all of a sudden, we have to replace the traditional metrics with the new AI pipeline metrics. Right? I heard many people talk about time to first token, right? GBs per CPU, TPS, and all these are new metrics that we have to take into account. And for agents, we need to look into context and memory. And all these things will bring new roles to storage. And if we translate that into infrastructure, we are seeing faster and faster network. The network, if you remember, for years, people wouldn't adopt the fast network for storage because they think the latency is enough. They think the storage speed and the network speed is fast enough. And all of a sudden, while the wheels of AI are rolling, we see adoptions of much faster networks, RDMA, etc. And for storage, we also need to look into, for example, KV cache acceleration, metadata, ontology, semantics, etc. So all these will point into an enterprise data platform, which will become the new foundation for intelligence. In any enterprise, there are existing infrastructures. But the idea in the AI era is to combine everything together and construct a solid foundation for intelligence. Largely consists of 3 layers. On the bottom, we still have to keep the data storage. We still need the performance, the capacity, the reliability, etc. However, we also want to add the data management layer, which consists of data catalog, data lineage. It's a whole bag of new things that wasn't or not the traditional of storage. And we also need to support all kinds of AI tool chains, like the data access, data enablement, model enablement, and also the application enablement. UCM is an open source project sponsored by Huawei that can build a unified cache management manager for KV cache. So without KV cache, everything will be in the HBM, which is very, very expensive. They try to tier it to RAM, and now we can tier it also to SSD. And with that, in some of the scenarios, you can see up to 90% lower time to first token. And there's other benefits. So I really encourage you to take a look of this project. Inside of an AI data platform, we basically turned storage from a passive repository into active intelligent layer, which continuously feeds, organizes, and enriches data for AI systems. Unlike old days, this AI data platform will take a variety of roles, such as a unified data lake. It will combine everything into an all-in-one fashion to serve the vectors, the embeddings, and training, etc., and inferencing. So the idea is that this AI data platform will keep the knowledge of the institute, keep the memory of agents, and manage your KV cache, and serve all kinds of applications, including the old applications and the new agent-based applications. And also, let's not forget about storage, cybersecurity. When AI is getting more powerful, the bad guys are the first bunch of people using it. So on the other hand, we have to make our systems better to defend itself. Ransomware protection is a big topic today, and we have to use AI to drive the ransomware detection and anomaly detection. The system will be able to automatically isolate the contaminated files or snapshots, and should also provide immutable storage and ransomware-proof backups. And it should also provide air gap for a fast recovery. So, to summarize, we have solutions to support all these things together, and we can change the traditional storage into an intelligence layer for the enterprise. And we have two systems, some are larger, some are smaller, and we're number one right now in the ML perf. So if you have projects, feel free to talk to our team. Thank you very much.
Thank you. Does anyone have any questions? Dan.
Hi. On your first slide, you had a power measurement showing an equivalent of 0.01 cents per kilowatt hour in the US? Way back.
This one? Oops.
Okay, one up, one farther. A little more down. Stop. Levelized cost of electricity. What is that? Far right. And how can you get that?
LCOE, okay. So
Yeah, and how can you get to that number with 50% proportion of wind and solar power?
%, you mean this number?
The number under it as well.
So this number?
The number below it, too. That one.
For this part, I need to check the details. Maybe I guess the reason is since you use a lot of the, for example, of the solar or wind power or such things, we can reduce the cost. But for the exact number, let me check.
I live in the Pacific Northwest in the U.S. All of our power is from 50-year-old or actually older hydroelectric products, dams. That's pretty much the least expensive electricity, and industrial rate there is about 12 cents a kilowatt hour. I think you might have a typo there.
Yes, you know that one difference from China and also from US, there is one difference. In China, there is an ultra-high voltage transmission network for the power. So based on that, we call it a robust power grid. For this one, we can use more of the green power, for example, like solar and also the wind, and to put it on the grid to travel, to transfer to other places. I think maybe that's the reason. Since China is I think maybe I guess maybe the leading country to use the green power. That's the reason. But for US, I know that US was once advanced for the power consumption. So even today, when we consider about the AI, we know that for example, even for the AI chipsets, the manufacturer, US sure better, and power consumption better, lower than China. But one advantage in China is we have more power supply and even the cheaper, much cheaper power supply. So for this number, I will check. I guess that's the reason.
So for the Ascent NPUs, that's a very interesting roadmap. I was wondering what kind of programs one could run on it. Can I run my generic C, C++ program, or do I need a dedicated ONNX or a PyTorch processing graph? And also, is this going to change for the 27, 28 next generation? Are you planning to like expand the scope of programs one could run on it?
Actually, for Ascend, yes. From the 2024, since Huawei have already joined the organization to support the PyTorch. So before that, actually, if you want to utilize the Ascend environment, you need to install our whole software stack. But after that, you can just use the PyTorch. There are some of the functions were provided by Ascend. For example, like the torch.mpu or such things, you can utilize that. Just utilize the PyTorch, and based on these functions. So I don't know whether I answer your question.
I was just wondering if you plan to expand that to some other platforms or beyond PyTorch.
Beyond PyTorch.
Specifically interested in just running generic programs on it.
Okay. For other than PyTorch, we also support for example, TensorFlow. For training part, we support TensorFlow and also support our Manspur. For the inference, we support, for example, VLLM and several kinds of the inference framework. Thank you.
Thank you.
Thank you.
Thank you.